13 multiple choice questions were asked from the chapter Matrices and Determinants in the January 2024 session of Joint Entrance Examination Main Mathematics. Out of those 13, we have already discussed 10 multiple choice questions in 2 discussions. In 2 discussions, we have already covered the first 10 multiple choice questions. The remaining 3 multiple choice questions we are now doing, and these questions are based on the concept of the solution of system of non-homogeneous equations, and we do it by a method called rank method. And we first get into the discussion and review what is rank method. We talk about the solution of a system of non-homogeneous linear equations by rank method. Now for this, we consider a system of m non-homogeneous linear equations in n unknowns x1, x2, etc. xn. This is the first equation. a11x1 plus a12x2 plus so on and so forth plus a1n xn is equal to b1. This is the second equation, etc. The last equation, the mth equation, am1x1 plus am2x2 plus so on and so forth, amn xn is equal to bm. We write down the matrix equation of this system of equations. The matrix equation of this given system is capital A into capital X is equal to capital B, where capital A is Aij m by n is called the coefficient matrix, and capital X is the column matrix of the variables x1, x2, etc. xn, and capital B is the column matrix of b1, b2, bm, and this is not equal to 0. If this is equal to 0, capital B is equal to 0, then it becomes a homogeneous system. That's a different case. So we take B not equal to the 0 column vector. And the procedure is, we first write down the matrix capital A along with the column vector B. The matrix A along with the column vector B. Then this matrix is called the augmented matrix of the given system. Now, the types of equations and solutions. First one is, when are these system of equations is called consistent. Consistent equations. If rank of A is equal to rank of A, B, that is the augmented matrix. If rank of the coefficient matrix is equal to rank of the augmented matrix, then the system is consistent. That means to say it has a solution or solutions. So when it will have a solution, that is a unique solution. So 1, unique solution. If rank of A is equal to rank of A, B is equal to n, the number of unknowns, then it is consistent and it has a unique solution. If rank of the coefficient matrix is equal to rank of the augmented matrix is equal to n, the number of unknowns, then the system is consistent and has a unique solution. Now, when the system has infinite number of solutions, if rank of the coefficient matrix is equal to rank of the augmented matrix is equal to R, where R is less than n, the number of unknowns, then the system is consistent and admits infinite number of solutions. Rank of A is equal to rank of A, B is equal to R, where R is less than n, then the system has infinite number of solutions. So what is the case left? When rank of A not equal to rank of AB, then what happens? Then it is inconsistent. So inconsistent system. If rank of the coefficient matrix not equal to the rank of the augmented matrix, then the system is inconsistent. That means to say it has no solution. Okay? So these are the various types of equations with consistent equations, inconsistent equations, and when it will have unique solution, when it will have infinite number of solutions. This is the discussion of the solution of a system of non-homogeneous linear equations by rank method. At times, this method seems to be easy for solving some of the questions. For that reason, we have taken up this one, and we will solve 3 multiple choice questions that have come in the January 2024 session JEE Main examination. So we go to the first question. This question has appeared in the JEE Main examination held on 30th January 2024 in the first shift. The given question is, consider the system of linear equations. So the first equation, second equation, third equation. And these are the 3 equations in 3 unknowns x, y, z involving lambda and mu. Right. And where this lambda and mu are real numbers, which of the following statements is not correct? We are given 4 options. Option 1. The system has infinite number of solutions if lambda is equal to 1 by 2 and mu is equal to 15. Option 2. The system has unique solution if lambda not equal to 1 by 2 and mu not equal to 1, 15. Option 3. The system is consistent if lambda not equal to 1 by 2. And option 4. The system is inconsistent if lambda is equal to 1 by 2 and mu not equal to 1. The question is asked if this in this fashion, then the rank method will be easier. So we are given 3 equations in 3 unknowns involving lambda and mu, where lambda and mu are real numbers. Then you have to discuss this system of non-homogeneous linear equations, and you have to find out which of the following 4 options is not correct. Not correct. That means 3 of them are true and 1 is not true, and you have to find out that option. We now discuss the solution of the problem. We have here these 3 equations and 3 unknowns involving lambda and mu. And we write down, the first step is to write down the matrix equation. Matrix equation is AX is equal to B. A is the coefficient matrix. What are the coefficients? 1, 1, 1, 1, 2, 2 lambda, 1, 3, 4 lambda square. This is the A. X is the column vector of unknowns, that is variables x, y, z. B, the values of these equations is column matrix 4 mu, 10 mu, mu square plus 15. So your next step is to write down the augmented matrix A with B. So you write the matrix A, put a screen and write the column vector B. So this is your A, this is your B. So after writing this one, what you have to do is you have to reduce this matrix into an echelon form. the so-called echelon form, what you call it. So you have to write down echelon form. To reduce this into an echelon form, you have to make this A21 position 0 and A31 position 0. To do so, we subtract the entries of the first row from the entries of the second row. Then you will get a 0 here, A21 position. So similarly, we subtract the entries of the first row from the entries of the third row. So that is what we do is R2 is R2 minus R1, R3 is R3 minus R1. Now if you do it, so then it is equivalent to, you will get this matrix. This matrix. Agree? After getting this one, to make into a echelon form, so the echelon form, so this two, that is third row, second position, this 2, you have to make it into 0. To do that one, R3 is same as R3 minus R2. If you do it, R3 is equal to R3 minus 2 times R2. 2 times R2. So if you multiply 2 times R2, that means so multiply the entries of the second row by 2 and subtract them from the entries of the third row. So that is R3 is equal to R3 minus 2R2. Then this becomes is equivalent to 2. This becomes this one. Now let's make it a simplification in the entries of the third row. So in the third row, 2 lambda, 4 lambda minus 4 lambda plus 1 is 2 lambda minus 1 whole square. And this when factorized will get mu minus 1 into mu minus 15. This is the echelon form. Why this is an echelon? It is like a ladder. So it's like a ladder. So it is called an echelon form. And we now discuss the nature of the given system and the nature of the solutions. So this is echelon form what we have. So we first talk about case 1. Let lambda not equal to 1 by 2. When lambda not equal to 1 by 2, 2 lambda minus 1 not equal to 0. This when it is not equal to 0, the rank of A is 3. And the rank of the augmented matrix is also 3 when lambda not equal to 1 by 2, irrespective of what the value of mu is. So that's, you'll get rank of A is 3, rank of the augmented matrix is also equal to 3, and this 3 is the number of unknowns, x, y, z, unknowns, number of unknowns, and it is irrespective of the value of mu. Then what you have, rank of the coefficient matrix is equal to rank of the augmented matrix is equal to the number of unknowns. Then the system is consistent and it admits a unique solution. Agreed? So that is the unique solution what you will get. Let's look at our options here. Options have come here, and the system, option 3, the system is consistent when lambda not equal to 1 by 2. When lambda not equal to 1 by 2, the system is consistent. That is option 3 is true. Option 3 is true. Option 2 is lambda not equal to 1 by 2, system is consistent and it has a unique solution, and it is irrespective of the value of mu. So even if you take mu not equal to 1 comma 15 also, no matter, and lambda not equal to 1 by 2 is there, therefore it accepts unique solutions. So therefore the options 2 and 3 are true. Agreed. Now if lambda is equal to 1 by 2, if lambda is 1 by 2, then this position will be 0. Then what will the rank of the coefficient matrix? It is 2. It is 2. And mu is equal to 15. This is also 0. So the rank of the augmented matrix is also equal to 2. is also equal to 2. So the rank of A is equal to rank of the augmented matrix is equal to 2, less than 3, the number of unknowns. Here we have taken mu is equal to 15 or mu is equal to 1. Any one of them will be okay. So 2 less than 3, therefore system is consistent and it accepts infinite number of solutions. So lambda is equal to 1 by 2 and mu is equal to 15. So go to the option 1. The system has infinite number of solutions. Yes. So option 1 is also true. Now let's move to the next option. That is the second case. If lambda is equal to 1 by 2, right? 1 by 2. If lambda is equal to 1 by 2, the rank of A is 2. Mu not equal to 1 and mu not equal to 15. That means this position is not 0. And this is 0. That means the rank of the augmented matrix will be 3. So the rank of A will be 2 and rank of A with B is 3. When lambda is equal to 1 by 2 and mu not equal to 1 and mu not equal to 15. Then the ranks are not equal, therefore the system is inconsistent and it has no solution. So what your option 4 says? Option 4 says the system is inconsistent if lambda is equal to 1 by 2 and mu not equal to 1. If just mu not equal to 1, it cannot be inconsistent. Mu not equal to 1 and mu not equal to 15. Suppose mu not equal to 1 and mu is equal to 15. Mu not equal to 1, mu is equal to 15. It falls in the above case, and it is 1 by 2 and mu is 15 and consistent, and it accepts infinite number of solutions. So it's just lambda is equal to 1 by 2, mu not equal to 1 by 1, and you are silent on mu, you are silent on the other value of mu, it cannot be consistent. So lambda is equal to 1 by 2, mu not equal to 1, and it will be inconsistent when mu not equal to 15 also. One more condition is necessary for this, and that condition is missing, and that is why this option is not true. So the option 4 is not true, and we have to find out that option which is not correct. Therefore our answer to this question is option 4. So that is the detailed discussion of the solution of the given question, and I am sure that you have understood the solution of this problem. Let's move to the next question. This is the second question, and this question has appeared in the JEE Main examination held on 30th January 2024 in the second shift. The given question is, consider the system of linear equations. These are the 3 equations in 3 unknowns x, y, z involving lambda and mu, where lambda and mu are real numbers. Then which of the following statement is not correct? It's just like the earlier statement, the earlier question, the last question, just like the last question. We are given the options. Option 1, system has infinite number of solutions if lambda is equal to 1 and mu is equal to 13. Option 2, system is consistent if lambda not equal to 1 and mu is equal to 13. Option 3, system has unique solution if lambda not equal to 1 and mu not equal to 13. Option 4, system is inconsistent if lambda is equal to 1 and mu not equal to 13. So if the question is given like this, in lambdas and mu different values are given, and to find out which statement is not correct, then the rank method is suitable. Right. Now we go to the solution part. Let's now discuss the solution of the problem, and these are the 3 equations, 3 unknowns x, y, z involving lambda and mu, where lambda and mu belongs to R, the set of real numbers. The first step, write down the matrix equation. Ax is equal to B. A is the coefficient matrix. A is 1, 1, 1, first row, 1, 2, lambda square, second row, 1, 3, lambda, the third row. and the capital X is the column matrix of variables x, y, z. Capital B is the column matrix of the given values 5, 9, lambda. Agreed. The next step is write down its augmented matrix A with B. So this is your A and the screen, and this is your B. So that is your augmented matrix what you have. So we continue, and right. So on this, make into echelon form. Make into an echelon form. Echelon form means you have to make this element 0, this element 0. To do that one, R2 is equal to R2 minus R1, R3 is equal to R3 minus R1. So make these elementary row operations on this to make it into an echelon form. It is equivalent to, we got this one. Then this is third row, second position. There is a 2. You have to make it into 0. For that, R3 is R3 minus 2R2. You do it. Right. You do it. Then you will get this one. Now simplify the third row. After simplification, you will get in the third row 0, 0 minus 2 lambda plus 1 into lambda minus 1 and mu minus 13. Here there are cases lambda is 1, lambda is minus 1 by 2. Two cases are also there in this, right? And this is the echelon form. After getting the echelon form, make the discussions. So we go to the next slide, and this time we have made it a tabular form. This is the augmented matrix A with B, and this is your echelon form. Agreed. Agreed. We make a tabular form. Values of lambda, mu, rank of A, rank of the augmented matrix, conclusion, consistency, and the solution, nature of the solution. Right. We take, first of all, first case, lambda is equal to 1. Lambda is equal to 1. And mu is equal to 13. Lambda is mu, lambda is 1. Then this will be 0. This will be 0. The lambda is 1. This is also 0. But anyway, the rank of A will be 2. And the mu is also equal to 13. This is 0. This is 0. The rank of the augmented matrix is also 2. They are equal. Conclusion is consistent. But they are equal to 2. 2 less than 3 number of unknowns. So 2 less than 3. And what is the nature? They are equal, therefore consistent. 2 less than 3, it has infinite number of solutions. So look at option 1. System has infinite number of solutions if lambda is equal to 1, mu is equal to 13. Yeah, it is true. It is true. So go to the next case. Lambda is equal to 1 and mu not equal to 13. When lambda is equal to 1, this position is 0 and the rank of A is 2. And when mu not equal to 13, this position is not equal to 0, whereas this position is 0. The rank of the augmented matrix is 3. And what is our conclusion? Rank of A is 2, rank of A with B is 3. They are not equal. When they are not equal, it is inconsistent and it has no solution. So look at your option 4. The system is inconsistent if lambda is equal to 1, mu not equal to 13. Yes, it is true. It is true. And we have to find out that option which is not true. Now take lambda not equal to 1, mu and lambda not equal to minus 1 by 2. I have told you that lambda has two values. Both are not equal. Both are not equal. Then both are not equal means this is not equal to 0. Then the rank of A, the coefficient matrix, is 3. And it is irrespective of the value of mu. Mu is 13 or mu not equal to 13, whatever it is, the rank of the augmented matrix is also 3. They are equal and equal to the number of unknowns. Therefore, it is consistent and it has unique solution in this case. So the lambda is not equal to 1 and lambda is equal to minus 1 by 2. So if you put lambda is equal to minus 1 by 2, this will become 0. This will become 0. The rank of A will be 2. And mu, if you take 13, the entire third row will be 0. And thereby the rank of and mu not equal to 13, then this position will be not equal to 0. And the rank of AB will be 2. Rank of AB is also equal to 2. So therefore they are equal to 2, less than 3, the number of unknowns, therefore it's consistent and it has infinite number of solutions. Now let's look at the option 2. System is consistent when lambda not equal to 1. Lambda not equal to 1. Irrespective, then lambda can be minus 1 by 2, lambda not equal to minus 1 by 2, whatever it is. So lambda not equal to 1 means you have to club these two cases. And mu is equal to 13. Yes, mu 13 or mu not equal to 13 is the first in this one. In this specifically mu is equal to 13. So if you club these two, lambda not equal to 1, mu is equal to 13. The system is consistent in this case. So this option is also true. So 3 statements have come in. They are also true. And the last case, lambda not equal to 1 and lambda is equal to minus 1 by 2. Lambda not equal to 1, lambda is equal to minus 1 by 2. This will be 0. The rank of A will be 2. And mu not equal to 13 we have taken, and this is not equal to 0, and thereby the rank of the augmented matrix is 3. So then they are not equal, therefore it is inconsistent and therefore no solution. Let's look at our option 3. The option 3 says system has unique solution when lambda not equal to 1, mu not equal to 13. Lambda not equal to 1, mu not equal to 13, we don't get, lambda not equal to 1, lambda not equal to 1, lambda not equal to 1, lambda not equal to minus 1 by 2, both the conditions, and mu not equal to 13, both the conditions, then it will have unique solution. But here you have lambda not equal to 1, mu not equal to 13, and it will have a unique solution is wrong. And if you take lambda is equal to minus 1 by 2, then it is inconsistent, no solution. So there should also be another condition on lambda. Lambda, if you want unique solution, lambda not equal to minus 1 by 2 also you need to have a unique solution. But here, lambda not equal to minus 1 by 2 is not there. Lambda is equal to minus 1 by 2 is there. So in that case, you will have no solution. Therefore, your conclusion that you are going to get a unique solution is wrong. So therefore, this option is not true. So we have to find out that option which is not correct. Therefore, the answer to this question is this option 3. So that is the detailed discussion of the solution of this problem, and I am sure that you have understood the solution of this question. We move to the third question, and is last question in this discussion, and this question has appeared in the JEE Main examination held on 1st February 2024, and in the afternoon session, I mean in the second session. The given question is, let the system of equations, you are given 3 equations, 3 unknowns, x, y, z, involving lambda and mu, where lambda mu are real numbers. And this system have infinite number of solutions. Then lambda plus 2 mu is equal to, we are given four options. Agreed. Now lambda, that means for what values of lambda and mu, this system has infinite number of solutions. For those values of lambda and mu, take lambda plus 2 mu and find out what is the correct answer. And for this, we are using the rank method in this discussion. But this type of questions I have shown you in the earlier discussion under matrices and determinants only by determinant methods. You can also apply determinant method for this, and that's also convenient for you. And this is also convenient. I wanted to show you under rank method. Right. We have this set of equations, three equations, three unknowns, x, y, z. Lambda, mu are the real numbers. First step, write matrix equation Ax is equal to B, where A is the coefficient matrix 1, 2, 3, 2, 3, 1, 4, 3 lambda. Right. X, the column matrix of variables x, y, z. B, the column matrix of the values 5, 9, mu. We write the augmented matrix A with B. So this is your augmented matrix. This is the matrix A, and this is the column matrix B, A with B. So we want to reduce this into echelon form. To talk about the ranks, you need to first get into an echelon form. So to apply the rank method, first step is to reduce your augmented matrix into an echelon form. So for this, you have to make this position 0, this position 0. To do that one, R2 is R2 minus 2R1. R3 is R3 minus 4R1. If you do it, then it is equivalent to this. Now again, this position is minus 5, which is, you want to make it 0. So to do that one, we have done R3 is equal to R3 minus 5 times R2. Then this will be 0. Then the third row will be like this. 0, 0, lambda plus 13, mu minus 15. So this is your now echelon. Echelon is here. So this is your echelon form. Now we discuss we don't discuss all the cases. We discuss only that case when the system has infinite number of solutions. Okay. Now let us see, if lambda is equal to minus 13, then this will be 0. The rank of A is 2. Mu is equal to 15. This is also 0. This is also 0. Then the rank of the augmented matrix is also equal to 2. Then rank of A is equal to rank of AB is 2. Less than 3, then number of unknowns. Then recall. Because they are equal, it's consistent. Because they are equal to R less than N, the number of unknowns, then it accepts infinite number of solutions. This implies the system is consistent and it has an infinite number of solutions. So we want when the given system has infinite number of solutions, and we have answered lambda is equal to minus 13 and mu is equal to 15. In this case, the system has infinite number of solutions. For these values of lambda and mu, required to find lambda plus 2 mu. Lambda plus 2 mu is minus 13 plus 2 times 15, that is 17. Let's look at our options. Our answer 17 appears against option 1. Therefore, the answer to this question is option 1. And that is the detailed discussion of this question. And thus we have come to the end of the discussion of these three questions what I have shown you by a rank method. And these are the three multiple choice questions, the last 33 multiple choice questions, which I have solved under rank method. And these are the questions that have appeared in the JEE Main January 2024 session. I am sure that you have understood the method by rank method, that is this method called rank method. And I am sure that you have understood the solutions of these three questions, and I wish you all the best. Thank you.